Okay, welcome everyone to the first afternoon talk. It's the most difficult talk to hold because everybody's tired from lunch. So hopefully the talk is interesting. I'm Jonas, working for EclipseSource. We are a company supporting our customers building tools in a variety of domains. Most of them are from engineering. And today I would like to talk about how to use EMF to build a tool for engineers. Quick background why I submitted this talk. If you look at the topic list here at EclipseCon, there are a lot of talks about new and edge technology like web-based tools, Java 11, Java 12, and all this stuff. And this is great. I mean, we're always innovative and we're thinking and talking about new technologies. Although I think it's also important to talk about the existing technologies which are actually there and are in use. So EMF is a perfect example. It has been there for 17 years now, but it's still not deprecated at all. There are hundreds and hundreds of tools based on this technology. There are new projects started using EMF. And the reason for that, it is incredibly powerful and it's very stable. So it's a very good choice for building tools upon. And if you do not want to be an early adopter and necessarily go for a web-based solution, but you basically just want to implement a tool in an efficient way, I hope I can convince you in the next 30 minutes that EMF might be a very good choice for you. Now, quick context. What is a tool for an engineer? We observe in a lot of customer projects and a lot of our user projects a very common scheme that many domains have a need for a tool in which an engineer of this particular domain can externalize some structured data. That might be in the car industry, like how parts of a car fit together. That might be in finance, how the contract works. That might be in engineering, how a machine is put together. So basically, those tools have completely different data models, but the purpose and the underlying requirements are very often pretty much the same. The general scheme, I would say, is instead of using Excel to manage something or to model your domain, you want a proper tool. However, you still have the need to build this tool as efficient as possible and to be able to evolve that tool if the business domain changes. So that's a typical use case. And it's surprising for us to see, I mean, we are not allowed to talk about any customer project, but for us it's always surprising to see how the requirements from different domains are really literally the same, just the stuff which is actually modeled is different. Now, typical use cases, what you actually do with a model, or with a structured data describing something in your domain. You do not just do that for the sake of doing it, but you try to gain benefit from this artifact. Typical cases, document something, for example, to send this to production, and then they actually produce a machine based on this information. To calculate something, for example, the cost of a machine. To validate something, for example, whether all the parts fit together or whether the power is enough or something like that. Now, so those are the tools I want to talk about today. And what I would like to talk about today, how to develop those tools. And that's where EMF comes into place. Cool thing about EMF is that it actually enables you to use modeling to build a modeling tool. So we can actually describe how the tool looks like, mainly using modeling technology, and generate a huge portion of the tool that we want to supply. And the advantage of that is, first of all, it's less effort. And second of all, if something changes in your domain, you can repeat that step, you can enhance your underlying meta model, and thereby adapt the tool. So the tool can evolve along with your business needs. So this is where EMF is used, and that's the, so we have a developer on the left side creating that tool, and this is the use case I want to talk about today. Now, what are the benefits, in a nutshell, of using EMF to create a tool? You have source code generation, especially about the entities, so you don't need to write your entity model from scratch. Those entities are more powerful than our handwritten code. They support change notification and a lot of more. I will give you some examples today. You have support for persistence. You can serialize your data without writing any custom code. You have undo redo support out of the box. There is support for model instance migration. So if you change a model, you can migrate existing data that users have already produced. You have support for tree-based UI, for form-based UI, for table-based UIs. There's support for versioning. So if your users check in or want to version the data, especially about comparing two instances. There's this reflective API. I will show an example for that, which is extremely powerful. And you can create, there are several frameworks to create graphical diagram-based UIs. In the remaining part of my talk, I will do a mixture between slides explaining what I'm doing and which technologies I use, and I will directly demo how to do that in my IDE, because I always believe seeing something is more credible than just talking about it. And I will cover all those requirements except the graphical one, because it just didn't fit anymore in the 30 minutes, so I'm sorry for that. I will give you some pointers on other talks that you can attend for diagram-based UI. Anybody wants to leave? No, good. Okay, so I will basically create an example tool throughout this talk. For example tool, I need an example domain. So I need a domain I want to provide a tool for. So what I selected for that is modeling a coffee machine. So the tool should be capable, or the user of the tool should be capable of modeling a coffee machine which consists of several parts like a control unit, a processor, dip tray, brewing unit, and so on. They can have all properties. The purpose of this tool could be an early design where you put stuff together, then you can do some validation, cost calculation, and then maybe communicate that to production department. Doesn't really matter exactly what the tool does, it's more about the general requirements, but I will use this as an example. Okay, first thing I would like to show some impression is how does modeling with EMF actually look like? And modeling in this context means how do I describe my domain in EMF and how do I generate code from that? So how do I teach EMF that there's, for example, an instance called machine, dip tray, and so on. So let me switch to the IDE. I've prepared some parts of the model already, because I don't want to bore you just to create a lot of classes, but I will show you how to add something to that. And by the way, in my workspace, that's the only thing that I prepared is I already created most parts of the model. Now what we see here is a class diagram showing my meter model. We see there is a common superclass called component, so everything in my model is a component. Components can contain each other, and I have some specialized components like a water tank, brewing unit, dip tray, control unit. Control unit has some more detailed properties already. So let's add a new entity here. Entity which is currently missing is the machine itself. So it's kind of the root node of my model. So I just add a new class here, call it machine, and then let me add an attribute to that. So machine should have a name of type string. So pretty much like you would expect from any UML tool, and this is a subclass of component. So now I've added a new class and I can just save, and this is the way how you would extend your model. Just describe your domain. Now so this is the graphical way. There's also a tree-based way. It depends a little bit on what you want to express, which one is more efficient. I think if you add a lot of attributes, then the tree-based one is typically more efficient. So this shows the same model. So we have component again, control unit, and so on. And if I click here, I see the references and attributes of this. I told you before, the purpose of the tool one example purpose of the tool will be cost calculations. And for that, I need to externalize the cost. So let's add an attribute cost to components so that the user can enter the cost of a specific component later on the tool. So for that, I right click here, I add an attribute, and now I have a form where I can enter the name. So this is cost, and the attribute type is, let's just do an integer. Okay, so that's the way how to extend your model or to start it from scratch. Now next step is to generate the code from that. That's actually pretty simple. I just open another artifact and click here to generate the model. So now in the background, the code generator produces Java classes. Now let's have a quick look at this Java class. I will not go too much in detail, but the new element that I just created called machine, we have here. It extends component, that's the interface, and it has a method getName and setName. So that's pretty much what you expect. If you manually created those entities, you would come up with the same. The difference is, so the code which actually implements those two methods is fully generated, and for example, the set method triggers a change notification, and you don't have to implement that. Also for reference, for example, it also supports bidirectional reference. So those are, I mean, implementing a getter is almost no work. Implementing change notification, references, bidirectional references, and all this stuff is quite some work if you do it manually without code generation. Okay, so that's it about modeling. Maybe one disclaimer, as I want to show you the full bandwidth of features, I will not go into technical detail too much. If you're interested in one of the particular frameworks that I've shown you, just talk to me anytime in the conference. I can show you more details if you like. Okay, next feature I want to show you, or combination of features, is a tree-based UI with undo, redo, and persistence. The reason why I show you those features in combination is that they all support it from scratch. You don't need to write a single line of code to get those. And the reason for that is EMF generates what's called the reflective API. That's very powerful. And what that means in a nutshell is that there is during runtime a description of all objects in your model. So for example, during runtime, you can retrieve which attributes a certain type have. And because of that, you can implement, for example, the serialization or a UI in a generic way. So you don't have to hard code it to one model, but it can actually adapt to your model. The same is true for undo, redo. Additionally, EMF generates what's called J-phase providers. Those are used to create a tree. So basically, they provide the structure of a tree and a label. So that's fully generated. And there are three components which access those two generated artifacts. That's a generic editor, which works out of the box for every model. It just looks at the reflective API and uses those providers to display an instance of your model. Then there are commands which support undo, redo, again using the reflective API, and there is a default serializer which can persist a model instance to a file or a resource. So this sounds all very abstract, let's just have a look. So what I will do is I will launch an example application. I have not written any code for this example application. So what it basically does is it integrates the editor to open an instance of my model, which you will see in a second. As you can see, this example application is just another Eclipse instance. Of course, you could customize that down to something which, for example, only has the editor, or embed this into your RCP application. Okay, so let's create an empty project here first. So we have a folder to place something. Let's call that test. And let's now create an instance of my model. So this is the use case that the engineer would do to model a machine. Now EMF creates a wizard for that. So if I type in coffee here, I see there is a wizard to create a coffee model that's generated. I can assign a file name. I can select the root node of my model. So as you can see, all the types are here. I will select machine, that's the new type that I just added, and then just click finish. And here we have the editor. Now this editor is fully reflective, so I didn't implement it, it's there. It will be there for your model too. Now what I can do here is I can modify stuff. So for example, I can give this a name. And now what you can see is the label provider updates. I can save it. You have default persistence. And I can create new elements. So for example, I can add a control unit to this machine, a brewing unit, a dip tray. So you see right-click menu is already generated. Undo, redo works. So if I must not use the key combination because you cannot see that. If I go here, I can undo the add, or I could redo that. So there's a full undo redo stack. If you ever implemented that manually, you know that that's a lot of work. And even drag and drop is supported. So If I want to, for example, drag this in the brewing unit or drag it back in the machine, everything is there, and again, with undo redo support. So this is really, really powerful, just out of the box, without doing anything. Now, you might wonder, I lied a little bit to you. So I told you this is fully generic and I didn't code anything. In fact, there are two things that I prepared. Probably you detected them already. One is the icons, because they're special. There's basically a folder where you can place an icon for every type. And to make the demo look nicer, I placed those icons beforehand. And the other thing that I prepared is this button over here, which I will use later in my demo. I just wanted to have an action where I can paste in some code. Besides that, there's no customization done on this editor. This is basically what you get for free. Now the last part of this demonstration is the default serialization. So if I open this, by default it's opened with this generic editor. However, the underlying thing here is actually a file. So it's an XMI serialization that you also get out of the box. So you don't have to worry about that. So let me open that again. So that's again the editor. Okay, let's continue with the next one. This is already a quite advanced feature, instance migration. However, that's in almost every project. Sooner or later, you get to the point where you need to migrate existing files. Now, the use case is you have created your tool, people start to use it, they produce instances, and at some point in time, you want to change your model. Now, the good news is whenever you add something in EMF, everything is typically completely compatible. So I could now add new classes, attributes, references to my model. Existing files would load, UI would update. I don't have to worry about that. However, there are cases where a migration is necessary. For example, if you rename an attribute. So that cannot work out of the box because, I mean, somehow the file needs to be loaded. However, luckily there is a framework for that. It's not EMF itself. But it's a framework or one of many frameworks which is based on EMF. The good thing about EMF is that the framework is so central, it's a very common standard to describe entities, and there's a variety of frameworks around EMF for different purposes. There's one for migration called EDAPT, and I would like to demo how that actually works. So let me close this application, let me close this editor, and go back to my IDE. Now let's assume I already deployed my model and now some department tells me, hey, model is fine, but we need for some strange reason, we cannot use the attribute name, we need to rename that to model name. And traditionally you would say, why do we have to do that? But let's just assume we need to do that. Now that means we need to migrate the instances because in the file, in the serialization, the value of this is stored under name. So how to do that? So first, I enable the EDAPT framework in my workspace. To do that, I open a particular view. So under EDAPT, it was already there, what's called the operation browser. Operation browser is a way to apply changes to my model. The only difference is that EDAPT will actually record those changes and thereby understand what you actually want to refactor. And with this information, EDAPT is capable of automatically migrating instances. Sounds spooky, but let's do an example. The first thing I need to do is to create a history file. So I can just click here and create a history. That's now a second file here, which contains the history, how my model was created. It has already contents. In fact, it contains a record for everything which my model already consists of. That's the way from 0 to now. The second thing that EDAPT provides is the notion of a model release. A model release is a certain state of the model that you have to that you deploy to your users. So I deployed the tool, so now I have release 0. So consequently, I create my first release before I change something else. So I just click on release here, and now you can see down here, I created my first release. That's release 0, the first state. And now I can actually change something in the model and record that with EDAPT. So to do that, I click the element that I would like to refactor, for example, the name attribute. And over here, I see a long list of things that I can change on this. There's really a long list of all operations supported. You can move attributes around, you can extract superclasses, you can merge references. So almost everything you could do with a model is supported here. For this demo, I will do the very simple case, just rename it. So just rename this attribute. And down here, I can enter the new value. So let's call it model name. And then I click on execute. Now you see the value has changed here and down here, and that's the important part. EDAPT has recorded that you have changed this attribute name, and this information is enough for EDAPT to migrate the instance during runtime. Now, to make that happen, I need to create release 1, because now I'm deploying a new version. For this, I can apply a name, so let me call that release 1, and then I save this. Now it is important that I regenerate my model too, because I've changed it. So let me regenerate that. Save first. Okay. Like this. And finally, I need to register this history files via an extension point. Basically, I need to tell the platform that this history file is there. So this is more a technical thing. Not too important, but it will not work if I don't do that. So let me register this file, and let me generate this again, because there's something, yeah, okay. Now everything is fine. Now I restart the tool, so in real world that would mean that the user of the tool gets a new version, but has an existing file. I don't clear the workspace because I want to have the old file that I created with version 0. Which would not load now if I don't have migration. So hopefully this works. So I double click that. And the generic editor that I've shown you before is actually integrated with EDAPT. So it checks the EDAPT framework whether there's a new version. And if so, it asks the user whether he or she wants to migrate. So let's double click. So it looks at the file. It sees that it was created with an old model version. It looks at the registry, it sees, okay, there is a new model version, pops up the dialog, and now if I click yes, it automatically runs the migration. And now we can see here, the attribute has been renamed, but the value is still there. Looks very simple. If you ever implement that manually, this migration, you know that this is pretty tricky to do. And if you have such a framework, that can really save you a lot of time. Okay, let's switch over to the next one. Forms and tables. I will also show that in combination. There's a framework. So you might have noticed that there are already forms over here. So for example, you see the cost attribute and so on. This is done fully reflective. So it just looks at the classes and shows a field for every attribute. However, you can make that more nice for your users with a framework called EMF Forms. EMF Forms adds an additional model to your project called a view model. And the view model can be used to describe how the UI should look like. And then there is a rendering component which translates this information during runtime into a form-based UI or a table. So it's a little bit like HTML, where you describe how the UI should look like, and then the browser translates that to the actual UI. So long story short, let's just do a demo. For the demo, let me close this. For the demo, I would like to use one instance of my model, and I want to show that a little bit more in detail. So we have not seen that before. The control unit. So control unit is one of the components. Control unit has quite some attributes and has sub-elements. So for example, a control unit can have a processor, it can have a dimension, it can have a list of RAM, and it can have a display. And now the goal is to show a UI which shows all interesting attributes of a control unit on one page, to not bury the user in a lot of subpages. And this is what I want to do with EMF Forms. What I want to do is show all attributes of the processor and a table showing RAM. So that's my goal. Now, to do that, I first need to create a view model. There's a wizard for that. provided by EMF Forms. So I can right-click on my model, select EMF Forms, create View Model Project. And that will create a new project. And now I can select which is the element I would like to create a UI for. That's the control unit. Down here, I can fill the UI, the view model already with a default layout. We will see in a second what that is. Now we have a new editor, also tree-based, which shows this view model. I'm not going too much into detail, but what you can see here, it currently controls a list of controls, contains a list of controls. Those represent the attributes you want to show in the UI. So there is a preview too. So if we look at this down here, this is how it would be currently shown. So there's a list of attributes, and that's what you get from scratch, but this looks pretty ugly. So I want to show the processor attributes, not the ones of the control unit. So let's remove everything and model this from scratch. Now, first I want to show the attributes of the processor. There are 6 of them, and I want to show them in 2 columns. So to do that, I create a container first. So there are layout elements. Let's create a group and call that processor. And in this group, I will create a horizontal layout. And in this horizontal layout, I create 2 verticals. You will get in a second why I'm doing that. Okay, so now I have 2 columns. And now in the first column, I can now add controls again. So those will show attributes. Now I can select which attributes I want to show here. It shows me the control unit as a root, but I want to show the attributes of the processor, so it can actually walk through my model instance. Now it shows me all attributes of the processor. Let's just pick the first 3 for the left column, and then repeat that for the second column. Again, processor. Now I can actually, because it's model-based, it even understands what I've done before, so I can show only the ones which I've not placed so far, and select all of them and just place the remaining attributes here. So that's how it works, and I think you believe, so this is very efficient. You could even do it for very large forms with a lot of attribute. So let's add a table too. Works pretty much the same. For the table, I need to tell the framework which reference to show, and I wanted to display the RAMs. So I select RAM, finish, and then I just click generate columns, and that will add the columns clock, size, and speed. This is all possible because there is a formal definition of the attributes, so it can actually just look at the model and just generate those columns. I could remove them now, but that's fine for now. Okay, so let's launch the application with this new view model. Again, this generic editor is integrated with EMF Forms, so it will, or it looks at a registry whether there is a view model for a certain entity, so I don't have to integrate that myself. So let's look at the control unit now. So now it looks much nicer. So I have my attributes on here, even widgets for all types, like for example for an enumeration here, and so on and so forth. I have a table displaying my RAMs, so I can add RAM here. I can enter something. I have features like copy paste, everything you would typically expect from a form-based UI. Again, just by describing what I need in a declarative artifact, and with the existing framework support, no coding involved. Let me mention a question that comes up very frequently. What happens with those technologies if I need to customize that? So what happens if I want my own widget, or if I want to have my own migration? All of those technologies typically aim at providing a good default case for you, but all of them are extensible. So for example, with this form, you could add your own widgets, like an own text field, or with EDAP, you can add your own custom migrations. That's not the issue. But they always provide you a good start. So you typically, and typical scheme is that you can fulfill kind of 80% of your requirements typically with what's there, very fast. And from there, you typically need to implement some customizations. But it's important that you save the first 80%. Okay, now versioning. So what happens if people change the model instance and want to compare 2 versions? good pattern is actually to check those files into something like Git or a database. And if you want to see the difference, then you want to compare two instances. There's a framework for that too. To show you that, I will not push something to Git. Basically what I will do is I will just create a copy of my model locally, because it's really about the compare, not so much where the two different versions come from. That's really something that you should solve or integrate in your own infrastructure, and it has no relationship with EMF. So let's just assume there are two versions and you want to see the difference. Now, I created a copy, and now let me rename, let's say, the machine in the first instance. And now what I can do is trigger a technology called EMF compare, which again uses the reflective API and doesn't work. Why doesn't it work? I haven't saved this. Okay, now it's dirty. So it uses the reflective API to again, reflectively compare those two instances. So without any adaptations, I get this. So it shows me a tree with a diff. I can click on that. I see a detailed view here, and it even supports merging. So if you would have a conflict, you could resolve that. So for example, let's see here, this is the change. This is my original version. Let's say I don't want to have this change. I just click here and save again, and now there's no difference anymore because I've merged the chains. And you can very easily integrate that, for example, with Git or a database or any system you use for versioning. Okay. Reflective API. Let's move fast. I promised you to have some cost calculation. I just want to quickly implement this cost calculation. What it is supposed to do is to calculate the cost of a full tree. And that's a good example where this reflective API is really powerful. What I've prepared for this, as I told you before, is this button in the UI. And this button will actually trigger a cost calculator. And that's a class which does the calculation. I don't have the time to code that now because we're almost at the end, but just let's quickly look at two parts of the code. Down here, the cost calculation is happening. What it gets in is a component. First, it retrieves the cost of this component, and then it uses here this method provided by, that's one of those reflective method, which allows you to get all contents of this node. So everything which is below in the tree can be retrieved with one call. And then I iterate over this iterator and just add the cost of all component here. And now we, at the end, this is actually sent to the fancy cost controlling system by the purchasing department. Yes? Yeah, but I know that I have components. So that's why I just call them. Yeah. The other thing which I have here is a very useful concept. It's called an e-content adapter. That's the way to listen to changes. And the special thing about a content adapter is that it will be notified about all changes in a tree. So even if I change the cost of any sub-element, this will be triggered. And it calculates the cost again and calls update cost on the cost controlling system. The cost controlling system is just any external system. So let's look at that in practice. And that's the last thing I would like to demo. Okay, let's open this. Let's enter some cost here. Let's say this is 12. Okay, and let's click on the machine and calculate the cost, and now be ready for the fancy cost system. Yay, 12 euro only. And now, as promised, now if something changes here, let's say this becomes more expensive, then it becomes red, but it's live update. So what do we do to lower the cost now as engineers? No, what we can actually do is we can add a component, and because we didn't check for that, we can just assign some negative costs here to trick, and now everything is green again. So made up example, but it just should show you that you can do or implement those calculations very efficiently if you, for example, have to iterate over the model and stuff like that. Okay. About graphical UI, I promised you some pointers. Look at the technologies GEF, GMF, Sirius, and Papyrus. If you want to do something UML-like, Papyrus is probably the most interesting one. There's a talk today about Papyrus. And Sirius, you also find talks here at the conference. And with that, I would like to conclude. Most important key or takeaway that I hope I could present is EMF is extremely powerful and feature-rich in combination with all the frameworks which are available. It is not deprecated at all, even if there are not so many talks anymore about the conference, but we use it in almost all customer projects, and we have every month we have new inquiries of people who want to start a new tool based on EMF. So it is a current technology, it's well proven, it's stable, and can be a perfect basis for a tool for engineer. I would say the typical use case is if you have complex data, people that need to enter complex data, you want to do some calculation, validation, and so on. You don't have thousands and thousands of users, but rather a small group, and you want to support them, and you want to be able to evolve the tool over time. So EMF can help you to achieve that in an efficient way. More information can be found under these links, and if you have more detailed questions, feel free to join us at our booth in the other room and ask me any kind of question, technical details, whatever you want to know. And I think we don't have time for questions, right? Sorry for that. Join me at the booth. Thank you for attending, and please evaluate this talk if you liked it. If you didn't like it, just ignore. Thank you.